Hey, welcome! So if you've ever been on a job site, just staring at a device that's suddenly offline, you know that deep, sinking feeling. It's frustrating, right? Well, today we're going to turn that frustration into a superpower. We're talking about the OSI model, but forget the dry academic stuff. We're going to treat it as what it really is, the most practical, powerful troubleshooting map you will ever have in your tool bag. Okay, so let's set the scene. You're on site, the client is kind of hovering, looking over your shoulder, and a critical camera is offline. Where do you even begin? Do you just start yanking cables? Do you dive into a dozen different software settings? The clock is ticking, and honestly, every minute you spend just guessing is money down the drain.
For a lot of us, this is the default mode, isn't it? Total chaos. We check the power, maybe recrimp a cable, we log into the device, we reboot the switch. It's just this frantic, inefficient scramble, hoping something, anything, will work. But there is a much smarter way to tackle this.
What you really need is a map. A logical, step-by-step process that takes you from, I have no earthly idea what's wrong, all the way to, aha, the problem is right here. This is the map that eliminates all that guesswork. It's what turns you into a precise, efficient diagnostic machine on any job you walk onto.
And that map, my friends, is the Open Systems Interconnection Model, or just the OSI model. Look, at its core, it's just a way of breaking down how data gets from point A to point B, say from a camera all the way to the video recorder. It takes this super complex process and slices it into 7 simple, manageable layers or steps.
And this right here, this is maybe the most important thing to remember today. For anyone who works with their hands, the OSI model is not some abstract theory you learned in a class once. No way. It is a practical, honest-to-goodness troubleshooting checklist. It tells you exactly what to check and, just as importantly, in what order to check.
Now, the full OSI model has 7 layers, which sounds like a lot to remember. But here's the good news. As a security tech, probably 90% of all the problems you're ever going to run into, they live in the bottom 3 layers. So that's where we're going to focus. We're going to master what I call the big 3.
So, we start at the absolute bottom, layer 1, the physical layer. And it's exactly what it sounds like. This is all about the stuff you can physically see and touch. We're talking wires, connectors, the actual hardware that makes up the bones of the network.
And this brings us to the first, and I mean the most important question on our entire checklist. Before you even think about opening your laptop, walk over to the network switch and look at the port. Is that little LED blinking green? If it's not, you have a layer 1 problem. Full stop. No amount of clicking around in software is ever going to fix a bad cable, a poorly terminated connector, or a device that's just not powered on.
Okay, so let's say you do have a solid green link light. Awesome, your physical connection is good to go. Now we can move up the stack to layer 2, the data link layer. This layer is all about how devices talk to each other when they're on the exact same local network.
You see, every single network device has a unique MAC address that's burned in at the factory. Think of it like a car's VIN number. It's totally unique to that one piece of hardware. Now, network switches use these MAC addresses to know where to send data. But, and here's a super common trap, some IT departments use a feature called port security. It basically tells a switch port, hey, only talk to this one specific VIN number. So if you swap out a broken camera for a new one, the switch sees a new unauthorized VIN and it just shuts the port down. Problem fixed.
All right, so your physical connection is solid and the local switch recognizes the device. We're moving on up. Now we get to layer 3, the network layer. This is the layer that handles sending data between different networks. Think about getting data from your camera network over a router to the server network. That's a layer 3 job.
Layer 3 uses IP addresses, which are kind of like the mailing address for your house. Unlike that permanent MAC address, an IP address is logical. It can be assigned and changed. And the ultimate test for this layer is a beautiful little command called ping. If you open up a command prompt and you can't ping your camera's IP address, you know for a fact you've got a layer 3 issue, like maybe an IP conflict or just a simple typo in the settings. So, just to nail this down, the layer 2 MAC address is the unique VIN number of the car itself. The layer 3 IP address is the house address it's trying to drive to. You absolutely need both of them to be working correctly for data to get delivered. And this right here is the whole point. This is why the OSI model is so great. It's a practical guide that tells you which tool to grab from your bag. If that link light is off, you don't need to waste time opening your laptop. You need a cable tester and a screwdriver. If the link light is on, but you can't ping the device, you don't need the screwdriver. You need to get on your laptop and check those IP settings.
So let's bring this all the way back to our original nightmare. The camera is offline.
But this time, instead of guessing and scrambling, we're going to solve it methodically. We are going to walk the stack, starting at the very bottom and working our way up, one layer at a time.
Look how clean and simple this becomes. You just follow the steps. Step 1. Check layer 1. Is that link light green? If it's not, you stop right there. You've found the problem. Fix the physical issue. If it is green, you move on. Step 2. Check layer 2. Log into the switch. Can you see the camera's MAC address in the table? If you can't, you've probably found your culprit. Could be port security, could be a VLAN issue. And if you do see it, you move to step 3. Check layer 3. Can you ping the IP address? If the answer is yes, you can be 100% certain the network itself is totally fine.
So what happens then? What if layers 1, 2, and 3 are all working perfectly? You got a link light, you see the MAC, you can ping it, but you still can't see any video. Well, now we can say with total confidence that the problem isn't the network hardware. It's time to look up the stack, at the software layers.
Real quick, layer 4 is about how the data gets sent. Is it sent reliably, like for a critical firmware update, or is it sent fast, like for live video streaming? And then layers 5, 6, and 7, that's really the world of the application itself, your video management software. The bottom line is, if you've proven layers 1 through 3 are solid, but the screen is black, you can confidently turn to the client and say the issue is with the VMS software, not the network you just installed.
And hey, if you ever need a quick and dirty way to remember all this, just think about ordering a pizza. Layer 7 is you calling and ordering the pie. Layer 4 is the shop deciding how to send it, reliable car or a fast motorcycle. Layer 3 is the driver using the IP address to find your street. Layer 2 is them using the MAC address to find your specific house number on that street. And of course, Layer 1 is the physical road itself. If the road is washed out, none of the other stuff matters, and you're not getting your pizza.
So, the next time a device drops offline, you have a choice. You can go back to guessing and hoping for the best, or you can pull out your mental map. With the OSI model as your guide, troubleshooting stops being this frustrating, mysterious art and becomes a systematic skill. And it's a skill that you can absolutely master to solve problems faster, more efficiently, and with more confidence than ever before.